I am amazing at Sudoku. Okay, that's a lie. But that's why today we are going to make a bot that can solve every single Sudoku problem in seconds, including the world's hardest Sudoku ever created. But as always, before we can make a bot to beat Sudoku, we need to make Sudoku. And for those of you that don't know how the game works, too bad. Nah, I'm joking. You start with a grid with some numbers already filled in, and you need to fill in the rest of the grid with more numbers. But there are rules. Each row can only have one of each number from 1 to 9. Same applies to columns, and same applies to each block. Okay, now you know how to play, let's get started. Okay, first we need to make a screen. Okay, so we've got a screen. Now we need to put some lines on it. And nice, we've got a 9x9 grid. And we want to make some of these lines thicker, just to show where each of the blocks are. And nice, there we go. So we can see where each 3x3 square is as well. So now we need a way to be able to select certain squares so that we can input the numbers into. Yeah, that's not working exactly as intended. Let's see why. Ah. There we go, fixed it. Although it is overlapping the lines a bit, so we kind of want to draw this before we draw the lines. There you go. And just beefed up the lines a bit, just to make it look a bit nicer. There we go, so we can deselect the square. So now we need to actually, this is just all visual, we need a way to actually store the grid and then input the numbers of the original grid that we want to use in, so that the bot can then go and solve it. So let's make a grid class so that we can input numbers in here and then store them. Okay, so I finally added the grid so we can input numbers here. And then this is like for filling out what the original grid will be like. So we'll get a problem, we'll type it in like this, then we click enter, and then that locks it into place. Then hopefully, once we've locked it into place, we'll be able to get a bot to solve through this. But firstly, we need to implement a way of checking when the bot inputs a number, is it valid or is it invalid? And we do that by using the rules of Sudoku. So now done it, where you input numbers and it'll check if it's true, or if it's false, this is an invalid solution, or even just an invalid board in general, because the 4 is in the column. And if we even put it in here, it's in the same square, so it's also invalid. But provided we put in numbers that aren't already in there, it's fine. But then say we put in another 4, or even a 9, just to show the column again, it won't allow us. 2 in the same row, false. So I'm going to make it now where when you do that, it's not just going to say false, it's just going to undo the move and not let you do it. Right now, if we try and type in a 3 here, it's not going to let us put it in, or a 2 and a 1, but if we try and put any other number it's fine. But back to 2, it's just going to not let us do it. This is useful then for when we're checking it with the bot, to rather than just allowing it from putting it in a number it shouldn't be, it's just going to stop it so that we can actually check and undo it if it's a incorrect placement. So but now we've actually got it here. So say this very easy board, but say this was the board, we could do it and fill it in. The blue is like what we're placing, what the bot would be adding, and the black is what's been provided already as like the problem to solve. And now it's time to make the bot, and the method we're going to use is a very simple brute force with backtracking. We start at the first empty square and input the number 1. If this is not a valid placement, then we increment the number until it's valid. Then we move on to the next square and repeat this process. If there is a square that has no number that makes the solution valid, we backtrack to the previous square and increment that number. This process repeats until the entire grid is full and the Sudoku is solved. This bot will always find a valid solution if there is one. Okay, so I've tested the Sudoku bot and it works. So it's time to put it to the test with some online Sudoku problems. So let's start with this problem here. I'm going to type in the problem and then see it solve it, and then we can input it into the online version here and see if it is actually correct or if my bot is just lying. Okay, so all inputted. Now all we gotta do is click enter and see it solve it. Wow, that was extremely quick. Right, time to type in the solution and see if it's correct. Now, this is the easy problem, so I'd like to hope it's got it right, and it has solved it very quick. That was real time there. Now, big moment. Are we correct? Congratulations. Now, let's see. Can we do a harder one? Let's do new puzzle. Let's do a hard one this time. I'm going to skip medium, go straight to hard. See how well the bot can do. And there are a lot more gaps in here, so a lot more places to go wrong and have to backtrack. I think the bot can do it. All typed in. Let's see the bot work this one out. Okay, a lot more backtracking going on, but it solved it. And again, time to check if it's right. How am I doing? Congratulations. That is very good. Now, before we do the hardest Sudoku ever created, we'll do one of the evil problems. Wow, that looks pretty evil. Again, all numbers entered in there. Let's see, how long will it take the bot? and solve. A little bit longer there, but you do sacrifice quite a lot of performance when I have to update the screen so constantly. If I did run that without updating the screen, it would only take, not even joking, like less than a second. So but let's get this inputted, and I think it's already correct. Do we really need to check? But let's do it anyways. Congratulations. Right, time for the world's hardest Sudoku. So here we are. Can you solve the hardest ever Sudoku? Well, I think we can. There's only one solution, and it took 3 months to design. Well, let's see how quickly we can solve it. So let's get this inputted, and then we'll let the bot do its magic. Okay, and we'll let the bot start in 3, 2, 1. We have solved the hardest ever Sudoku in a few minutes. So, probably the first algorithm I've written that has actually worked pretty good. So, practically solved Sudoku, going to have to find something a bit more challenging for the next video. And thank you guys for watching this video today. Make sure you check out my channel for my other videos and subscribe so you don't miss the next upload.